In this video, we'll look at multiplying and dividing rational expressions. The expression we're given is 2 times n squared minus 7n plus 12 divided by n squared minus 6, and that's all divided by another fraction, 5 times n minus 4 over n squared minus 4. Okay, well, let's put an equal sign here. First thing I want to do is factor this expression, n squared minus 7n plus 12. So for that, I'm looking for what multiplies to, what adds to, what are the two numbers. I'm trying to multiply to 12. I'm trying to add to negative 7. If you don't know what I'm doing here, I suggest you watch the video on using Bergman technique. Nevertheless, what multiplies to positive 12 adds to negative 7? The numbers are negative 3 and negative 4. I just did trial and error in my head. So I can replace this expression here with 2 times n minus 3 times n minus 4. Top part done. Bottom part. I gotta do n squared minus n minus 6. Again, Bergman technique. What multiplies to negative 6 and adds to negative 1? Just quickly in my head, the numbers are negative 3 and positive 2. To think about that. It multiplies to negative 6, adds to negative 1. So on the bottom I get n minus 3 and n plus 2. My first step's always going to be factoring. I still got to factor the other side, or the other fraction. The top part's already done. It's just 5 brackets n minus 4. That's factored. The bottom part, if you don't recognize it, I recommend the video on difference of squares. This is just a difference of square. So, watch that video if you don't know what I'm doing here. This is just n minus 2 times n plus 2. Make sure this fraction goes the whole way. And now I've got it completely factored. Step 1 is factor. Step 2 is record my restrictions. I'm going to need to record what n can't be. So n cannot equal whatever would make this denominator 0. So n can't be 3, or this would be 0. N can't be negative 2, or this would be 0. N can't be positive 2, or this would be 0. And this last one I've already got. N can't be negative 2. So factor, record my restrictions. Next step is I'm going to leave the first fraction alone. Just rewrite it. 2n minus 3, n minus 4 over n minus 3, n plus 2. And for the second fraction, when you're dividing by a fraction, it's the same as timesing by the fraction flipped. Divide by a fraction is same as times by the fraction upside down. And that's good because now I've got everything timesing. I can start to simplify. So factor, record restrictions, change the divide to a times by its flip. And now I can start to cancel. Just before I do though, I better make sure I didn't introduce any new restrictions. I flip this fraction, now there's this n minus 4 on the bottom. That means n can't be 4, which I didn't have, so I better record that restriction, n can't be 4. So make sure you check that second time to make sure you've got all the restrictions. Now cancel out, it's all timesing, so cancel out any factor on top with a matching factor on the bottom. There goes the n minus 3. On top of here I have an n minus 4 and an n minus 4, so they cancel. And here I have a matching n plus 2 top and bottom, so they cancel. What am I left with? On top, a nice simple 2n minus 2, leave it factored, all over just 5. Important note, a lot of people make this mistake. Your final answer is not just an expression, it's an expression with the restrictions, and I need to state those restrictions in order. N cannot equal, in numerical order, negative 2, or positive 2, 3, or 4. And I've done it. We did multiplying and dividing rational expressions. I first factored every part of the expression. Then I recorded my restrictions. Then I changed divide to times by its flip. I recorded any new restrictions that created. Then I canceled out and stated my final answer with restrictions. All done.